Hello guys and welcome to Mossy Maths with me, Tom Moss, and today we're going through the third lesson on the topic of coordinate geometry. In this lesson we'll be looking at parallel and perpendicular lines. Now for those of you that have seen my lesson on differentiation, we went through this. However, we went through differentiating a function to find the gradient. This is similar, however we've already given the gradient in the question, in the way it's worded, and I'll show you what I mean when we go through these 4 examples taken from the latest AQA revision guide. So, let's start with this question here. It says find the parallel to y equals 3/4 x minus 7/4 that A has a y-intercept of 0,4 and B passes through the point 3 minus 1. So let's start with A. Well, hopefully we're aware of the equation of a line that we need. This is the equation of a standard line. This is your y value, this your x value, the m stands for the gradient, and the c is the y-intercept. And this is how we write the equation of any line. So the first thing we need to do is look at the question, which says find the parallel to this. So what does parallel mean to start with? Well, hopefully you're aware that a line that is parallel to another line will move in the same plane as it. So it will carry on forever in that same direction. The lines won't ever diverge or converge together, they'll just carry on at the same distance forever. So what that means is they must have the same slope. They can't have a different gradient, otherwise they would diverge or converge. So, if the gradient is the same, then we can say that the gradient of this line must be equal to the gradient of the parallel. So our gradient of our new line must also be 3/4. Okay? M is the number in front of x, the coefficient of x, which is the gradient, 3/4. So now what about the y-intercept? Well, it says here it's got a y-intercept at 0,4. It crosses the y-axis at the point 4 on the y-axis. So we can say that our equation of our new line is going to be y equals, well, our m value is 3/4 x, plus our c, which in this case, it tells us is at the point 4. So that's the equation of the line. That's quite a basic example. Now let's move on to the second one, where it says that it passes through the point 3 minus 1. Now this is more difficult because we're given coordinates. So, 3 minus 1. Again, the gradient's going to be the same. It's still parallel to this. So we're still going to have an m value of 3/4. Okay? This is for part B. Okay? So we now need to calculate the equation of the line with these coordinates. And the equation we use at AS level is not the same as y equals mx plus c, which you may have seen from GCSE. We have to use this. Now unfortunately it seems more complicated, and it does indeed give us the same answer, but in the mark schemes of AQA exams you will see this equation here as opposed to y equals mx plus c. So this is what we have to substitute the values into. So we substitute these in. So we say that y minus, now our y1 is the value of y in the question, minus 1. This is equal to our m, which is our gradient, 3/4, multiplied by x minus our x1, which is the 3 in the coordinate. Now actually, in an exam they can accept this as an answer. This can be full marks. However, with exam boards changing, I don't want to leave it in this form because you never know, they might start asking you to simplify this down into the form y equals mx plus c, for example. So I would always expand this and simplify it just in case. So here it's going to be y minus minus 1, that's y plus 1, is equal to 3/4 times x, 3/4 x, minus 3 times 3/4, which is just going to be minus 9/4. The next thing we could do to get rid of the fractions is multiply everything by 4. Doing that, we get 4y plus 4 equals 3/4 times 4, that's going to be 3x, minus 9/4 times 4 is 9. And now we can get this in the form 4y equals. And it's going to be 3x, now minus 9, we're going to move this 4 across to become a minus 4. Minus 9 minus 4 is minus 13. So there's the answer to this question. Now let's have a look at this one here. Find the parallel to 2x minus 8y plus 11 that passes through the point 3 minus 1, giving your answer in the form ax plus by plus c is 0. So, first thing we need to do, once again, if you like you can pause the video and have a go at this. So, with this question we need to get this in the form y equals mx plus c. Remember, m is our gradient. We can't just look at the coefficient of x because this isn't in the right form. We've got it in the form equals 0. So this is not our gradient. We need to get this in the form y equals. So let's move the minus 8y across to become positive 8y to start with. If we move that across, we're going to get 8y equals 2x plus 11. Now, we need this in the form y equals. So we divide everything by 8 to get just one y. In doing that, we have to divide this by 8 and this by 8. And we can simplify this. 2 eighths is a quarter, and this will just remain 11 divided by 8. Now, this is the point where we need to look at the coordinates. It's similar to the previous question. In fact, they're the same coordinates. And we're going to be using that same formula. Y minus y1 equals m brackets x minus x1. So, our gradient is parallel still, so our gradient is going to be this m value of a quarter. So, y minus our y1, which is minus 1, equals our gradient multiplied by x minus our x1. Expanding this, we get y plus 1 equals a quarter x. Now minus 3 times a quarter, that's minus 3 quarters. And now we do the same thing here, multiply everything by 4. 4y plus 4 equals x minus 3. And we can simplify this to get it in this form. The x is at the front here. It doesn't really matter what order you put the terms in, but I'm going to do it in this form just in case. It's always worth doing it in the way the question tells you to exactly, so that you don't lose any marks. So let's leave the x in the front. So you're going to have x. Now, if you subtract this 4y, you're going to get minus 4y, because it's positive on this side, minus 4y, plus our constant, and it's going to be on this side. So we need to move the positive 4 across, which is going to become a minus 4. Minus 3, minus 4, that's minus 7. And this is now going to equal 0 on this side. Okay guys, now we're moving on to the second part, where we're finding the equations of the perpendicular. This is harder because you have to find something called the negative reciprocal to find the gradient, which just means we find the inverse of the fraction and then we swap the sign as well. I'll show you exactly what I mean. Find the equation of the line perpendicular to y equals a third x minus 1 that passes through the point minus 2, 4. Okay, so what does perpendicular mean to start with? Well, it means this. It means you've got a line, maybe this one, and another line will intersect it, or it will travel in a way that is at right angles to this line. As you can see, this is at right angles to this, at 90 degrees. So the perpendicular is the line travelling at 90 degrees from it. So the gradient, you can see, is going to be the negative reciprocal. So what I mean is, we've got this in the form y equals mx plus c. So if this was a parallel line, we'd say the gradient was a third. But it's not. We need to take the negative reciprocal, because it's perpendicular. So all we do is we make this a negative, because it's positive. If it was negative to start with, we'd then make it positive, okay? So we make this a third negative, and then we flip the fraction over. And hopefully you know that 3 over 1 is just 3. So we're going to get minus 3. And that's all the negative reciprocal is. And this is our gradient of our new line. And now we just do the same as we would for any other question. Okay? So y minus our y1, 4, equals our gradient, which is now minus 3, the negative reciprocal, multiplied by x minus 2. Remember the double negative. So we're going to get y minus 4 equals minus 3 times x, minus 3x. Now this inside the brackets will become positive. Remember the double negative. And we're multiplying this positive 2 by a negative 3. So we're going to get negative 6. And then it doesn't ask for a particular form, so this would actually get us full marks, but we'll put it in the form y equals mx plus c to guarantee we do get that full marks. So doing that, we have minus 6, this is going to become a positive 4, minus 6 add 4, it's minus 2. So there's the answer to that question. Now let's move on to the final example, which is the hardest of all of them. Find the equation of the line perpendicular to 7x minus 3y plus 5 is 0 that passes through the point minus 3 minus 11. If you like, you can pause the video and have a go yourself. I'll go straight through it with you afterwards. Okay guys, so with this one, again, we're going to have to rearrange this to get it in the form y equals, so we can look at our gradient. If we move the minus 3y across, we get 7x plus 5 equals 3y. And now we divide everything by 3 to get this in the form 1y equals. So y equals 7 divided by 3x plus 5 divided by 3. And from this we can see our gradient would be 7/3. But again, this is not the parallel. This is the line perpendicular to this gradient. So we need to take the negative reciprocal. This is positive, so it's going to become negative, and we flip the fraction. So our new gradient is minus 3/7. Now we substitute it into the equation. Again, y minus our y1, which is minus 11, equals our new gradient, minus 3/7, multiplied by x minus 3. We've got two double negatives here, so we've got to be very careful when expanding these brackets. So y minus minus 11, y plus 11, equals minus 3/7 x. Now, minus 3 is going to become a positive 3 inside the brackets, and we're multiplying that by a negative 3/7. So we're going to get minus 9/7. Okay? Then we multiply everything by 7 to get rid of this fraction. 7y plus 77 equals minus 3x minus 9. And now we can get this in the form y equals, or we could get this in the form where this all equals 0, which we did in this question, so we'll do that. 7y, now this minus 3x, if we move it across, will become a positive 3x, plus 77 plus 9, this is going to become a positive 9, is going to be plus 86. And this is going to equal 0. So there's our answer to the final question. So these are on parallel lines, these are on perpendicular lines. Okay guys, so hopefully you followed that lesson. If you did find it helpful, then please put a like. And if you do have any questions, do put a comment and I'll get back to you as soon as I can with an answer. In the next lesson, we'll be moving on with the topic of coordinate geometry and looking at how we can maybe sketch cubic functions as opposed to quadratics, which we may have seen in a previous video. So thanks a lot guys, and I'll see you in lesson 4. Thanks.